Hello, Mr. Myers here, and I'd like to take a few minutes to talk about binary ionic compounds and how we can go about taking ions and writing the formula correctly in order to balance the charge. Part of the assignment today is to be able to fill out the entire table with the correctly balanced chemical formulas. But before we do that, I want to talk about how we do this. So I'm going to use the blank space in the bottom. And again, our topic is binary ionic compounds. And these are consisting of two elements, specifically two from binary. Because it's ionic, we have a metal and a non-metal. So just those two elements. And our goal when we are presented with two different ions, so for example, Na plus and H minus, our goal is to be able to balance the charges to achieve a neutral compound. All right, so we want to balance the charges to get a neutral compound. That means there's zero charge. And again, this is only with ionic compounds that this will work. So let's take this example here of Na plus and H minus. Sodium is the, I'll write it over here. Sodium is the cation, and H minus is the anion. And they go together because positive and negative, those opposites attract. So let's set it up. We've got Na plus, H minus. Now I'm going to show you something called the crisscross method. This method works very well in order to get us to a point where we can correctly balance the charges to get a neutral compound. So here's how we do it. We look at the value of the charge, and we crisscross it to the other element. So if we look at the one here, this one's going to go down as a subscript for H, and this one is going to go down as a subscript for Na. What results is Na1, H1. We effectively are ignoring the sign of the charge and focus just on the value. Now, anytime we have a 1, we don't have to show it. The 1 can be implied. So the other version of this that's slightly more correct is to write NaH. There's 1 sodium and 1 hydrogen. And if we look, the +1 and -1, those balance out to 0. Let's look at another example. Say you have barium, which is a +2, and oxygen, which is a -2. Now, if you look at this, I see a +2 and a -2, and I add them up, they get to 0. And so that can tell me that the formula is just BaO. But if you're not that quick, go ahead and crisscross the charge values. Doing so would say that this 2 comes down by oxygen, and this 2 goes over by barium. The result is Ba2O2. And this can be reduced to BaO. You may remember from John Dalton in his atomic theory stated that atoms combine in whole number ratios. When it's ionic, we say it's a simple whole number ratio. In other words, if the ratio between the subscripts here can be reduced or simplified, do it. So BAO is our correct choice. Okay, here's yet another example. If we take zinc plus 2 and carbon minus 4, or 4 minus, we're going to crisscross these charges. The 2 comes down to carbon and the 4 down to zinc as subscripts. So we get Zn4C2. And you might notice, well, 4 and 2, those are both even numbers, so we can reduce or simplify this ratio. We can reduce it to Zn2C, where it's a 2-to-1 ratio. Always simplify if you are able. And that's it.